Welcome to our paper Veritex, Variational Neural Phase Textures. My name is Marcel, and this is joint work between ETH Zurich and Google. These are synthetic images of unseen identities from state-of-the-art generative models. Impressive results. But what happens if we rotate the head pose to the side, for example, in a virtual or augmented reality application? The outputs suffer from strong artifacts, and sometimes they fall back to a less extreme pose. The problem is that these methods are trained on a dataset that is strongly biased towards a frontal head pose, and they struggle to extrapolate to more extreme poses. In this paper, we train on the same dataset, but for the first time, our method overcomes this bias towards frontal faces and synthesizes extreme head poses for unseen identities. Our method is Veritex, Variational Neural Phase Textures. It's the first model that can generate neural phase textures for novel identities and render extreme head poses while controlling expressions. Veritex is a generative model. It can sample latent codes for novel identities and use the graphical controls to render extreme poses and expressions. Here's a description of our neural rendering pipeline. The inputs to our method are a latent identity code, sampled from a learned distribution, and graphical control parameters for shape, expression, and pose. With these parameters, the face model generates a UV map. Given that UV map and the latent code, the neural rendering pipeline generates an RGB image and a foreground mask. Now let's zoom in into the neural rendering pipeline. Given a latent code, Veritex generates the neural textures in the face texture decoder. The UV map samples these textures to a neural feature image for the face. A second decoder then enriches the neural feature image with the missing regions, like hair or the mouth interior. And finally, the feature images turn into an RGB output and a foreground mask. The Veritex framework allows to sample new identities and interpolate in the latent identity space. It also maintains high consistency for changes in head pose and facial expressions. For the face interior region, the 3D models enables our method to generate very consistent faces. And unlike previous generative methods, we generate more extreme viewpoints. The method has no access to the geometry of the exterior region, and it has no temporal component, and therefore the per-frame predictions are plausible, but might not be consistent over time. In contrast to existing methods that require strong supervision in the form of multi-view images or videos, we train only on unpaired monocular RGB images in a self-supervised setting. Now, directly reconstructing the original image yields artifacts, and therefore we reconstruct an affine transform variant. Our method expects known facial geometry, so we fit a 3D morphable face model, which yields parameters for shape, expression, and pose, with which we generate UV maps. An encoder maps the mask input image to a latent Gaussian distribution. We sample a latent code and run the neural rendering pipeline as described before. The final objective function consists of self-supervised reconstruction terms, the discriminator loss, and the regularization term in the latent space. Now let's see some results for controlled and identity-consistent face synthesis. The face model gives us artistic control over the output. We render two identities with a frontal pose and a neutral expression. We then change expression and pose. And finally, it's also possible to render faces with expressions and poses extracted from real reference images. We conduct extensive comparisons, as well as a perceptual user study, and show that our method clearly outperforms related works for identity consistency. We also provide a demo notebook. Make sure to check it out. To summarize, UV mapping and the differentiable rendering pipeline enable consistent renderings of extreme poses, even when trained on mostly frontal face images. Please check out our project page for all resources and demo. Thank you for watching.